Hello students, this is Mrs. Crawford. I'm going to be going over the block day lesson on exponents from this week, where we talked about dividing with exponents and also doing combinations, so the rest of that page that we started on Monday. I do want to really quickly go over a couple of the problems that you guys did for independent practice on Monday, just to make sure you did know what you were doing, and it's a good review to start off. When you're multiplying, remember you're really adding the exponents, but you don't change how you deal with coefficients. So, for example, -4 times 3, you do that just like normal. So -4 times 3 is -12, just like usual. It's the exponents where you do something different. C to the second times c to the fourth. Remember, c to the second looks like this. C to the fourth looks like this. So if you put it all together, it's not 2 times 4, it's actually 2 plus 4, which is c to the 6th power. With this one, the 8 and the 3 here are a coefficient, so those are going to get multiplied just like normal, so that should have been 24. And then you should have added the exponents, so r to the 11th, r to the 3rd, r to the 8th, together makes r to the 11th. Last one, you have 6 and 7. Multiplied together, we get 42. Now, at this one, you do have to be a little bit more careful because you do have two variables. You've got f squared, or f to the second power, and then just an f by itself, which is really f to the first. So be careful about that. It's not f to the 0 power. Second plus first, add those two numbers together, you get f to the 3rd power. And then finally, you have g to the 4th, g to the 2nd. If you add 4 and 2, you end up with g to the 6th power. So those were the answers to the multiplication section that we did before. A couple places where exponents are actually applicable. We're going to be kind of talking about these throughout the lesson. One of the places is population increase. For every one person, if they have 4 children, and then those 4 children have 4 children, you get what we call exponential growth. And it exponentially grows through the years, where you might have started with 1 person, and now you're up to over 200 people very quickly. Think about if any of you guys have really, really big family reunions. It might have started with grandma, grandpa, but they had 5 kids, including your parents, and your parents had kids, and now everyone's just getting lots and lots of exponential growth. So that's a way that we see exponents used, is looking at how populations grow and even how they decrease sometimes. Alright, so here's the second section of our notes, dividing with exponents. So when we divide, we're actually going to be subtracting the exponents. We still divide the coefficients like normal, and you can only combine things with the same base. So pretty much like what we did before, just this time we're dividing instead of multiplying. So pause there, copy those down, and then we'll move along to the next one. Alright, so I do want to show you why you subtract the exponents, because it seems kind of silly not to divide them, so let's look at why that's the case. F to the 6th power really means f times f times f 6 times. That's what 6th power means. F to the 3rd means 3 times. Well, what happens when you have something divided by itself? Well, 10 divided by 10 is 1. 100 divided by 100 is 1. 5.365 divided by itself is 1. Doesn't matter what you do, if you divide something by itself, you get 1, which means f divided by f is also 1. Well, if this whole group is just going to change to 1, do I really need it there? I mean, 1 times anything is just itself, so it really doesn't change the rest of the problem, so I can just get rid of it. Same thing with this guy and this guy, which means I only have these 3 f's left over in the top right-hand corner. That is why when we do division, we're actually subtracting the numbers, so it's not f to the 2nd power, it's f to the 3rd power, because 6 minus 3 is 3. Over here, kind of similar to what we did before, we pay attention to those coefficients. We have 6 divided by 2. You're not going to do anything different with those. 6 divided by 2, you can either realize that 6 divided by 2 is just 3, or you can reduce the fraction. If you divide both of them by 2, you get 3 over 1. Same thing as 3. Now you do have to be careful because we've got a fraction now. It's still 12 minus 2 because they are the same base, W and W. However, because there's more in the top, that's where the answer has to go. So I'm going to say that again. There's more W's in the top, so that's why your W to the 10th power has to end up going there. This one is kind of tricky. Be really careful with those exponents. Got negative 8 over 16. It's not negative 2. Be really careful about that. Reduce your fraction. You can divide both of them by 8, which means you get negative 1 over 2. So that is what you put into your next part of the problem. Negative 1 goes on top. 2 goes on the bottom. Do not put just negative 2. That is not what that equals. You've also got s to the third, and this is really s to the first power. Remember, when we're dividing exponents, we're really subtracting their numbers. I have more of them on the top, so that's where my remaining s's are going to end up going. So now I have s to the second power on the top. Alright, and then we also have the h's to look at. If I look here, I've got h to the 7th power over h to the 4th. There's more in the top part of the fraction, the numerator, so I'm going to keep my answer there. 7 minus 4 leaves me with h to the 3rd power. Alright, so you guys are going to go ahead and try these next couple ones. When you're done, oops, that's not what I wanted to do. Just wanted to get rid of these. When you're done, I'll show you what the answers are to them, but at least try these yourself, otherwise you're not going to really know where your mistakes are. You're just going to have copied down the whole video. So please pause here, try them yourself, and then I'll show you the answers. Alright. First one, we've got n to the 7th over n to the 1st. So you should get n to the 6th power there. This one, 6 and 16, I can divide them both by 2, which means I have 3 on the top, 8 on the bottom. X to the 14th, x to the 7th. If I subtract those numbers, I'm going to get x to the 7th, and it's got to stay on the top because that's where more of the numbers are. Last one, 12 and 9. I can divide both of those by 3. 12 divided by 3 gives me 4. 9 divided by 3 gives me 3. And then I start looking at my exponents. I have p to the 6th power, p to the 2nd power. There's more in the numerator, so I'm going to keep my answer up here. 6 minus 2 gives me 4. And then this one's kind of interesting. I've got y to the 5th over y to the 5th. If I was to actually write all that out, it would look like this. And all of the y's cancel out, which means I shouldn't write a y here at all. It's not y to the 1st. It's not even y to the 0. It's gone. It's canceled out. If it's the same top and bottom, kind of like 3 over 3 is just the number 1. This is equal to 1. I mean, I can put a 1 there. But what's anything times 1? Itself. So it's kind of redundant. I don't really need it. So that's my final answer then. Okay. Another quick area where exponents are super important is sales. Think about smartphones, right? They came out in kind of the mid-2010-ish area. 2008 it looks like, actually. And at first we didn't have a lot of people with smartphones, but it grew and grew. Apple does a really good job of advertising their material. So it very, very quickly got up to here in 2012. Looks like it's 35 million, somewhere in there. And I would bet today we even have more of them out on the market. So that is actually an example of exponential growth. This curve is indicative of exponents. That curve there shows that. So that's what we call exponential growth. A lot of things that gain popularity very quickly can be represented by exponential graphs. And a lot of the business people who look at that, they track that info to see what their best product is, what aspects of that product worked, how many people are looking at it, all those kinds of things go into it, and it's all based on exponents. Alright, the last section is combinations, and really that just means that you have to do some multiplying and some dividing in the same problem. So first of all, our rule is you want to do everything in the numerator. Just get all the multiplying you can done first. Do everything in the denominator, same thing there, do all the multiplying first. Then move top to bottom. Do the dividing stuff afterwards. So go ahead and fill in those blanks. Okay, so I'm going to take this problem 1/2 at a time. So just like my notes just said, I'm only going to deal with the numerator first. And it doesn't want to let me drag it, but that's fine. Whatever, that's fine. There we go. That was going to bug me. Alright, so in the top one, we only have one coefficient, the 4. So I'm just going to rewrite it over here. We're not doing anything with it yet. If there was another coefficient, then I would have to multiply, but there isn't. I've got x to the 6 times x to the first is really there. Think back to your notes, even look up at the top of your page. What do we do when we multiply exponents? If you're multiplying, you're really adding all of them up. So 6 plus 1 is x to the 7th. And then we've also got y to the 8th. Nothing's getting combined with that there, so I'm just going to leave it where it is. And let's see if I can drag this up. Alright, so I dealt with the numerator. Now I'm going to do the same thing in the denominator. Again, just a 6 there, nothing else. So I'm just going to rewrite it off to the side. X to the 4th, there's no other x's here, so I can just rewrite that guy as well. And then I have y to the first power, because it's by itself, times y to the second power. Well, if I combine all those together, I get y to the third power. So that's my answer on the bottom. Okay, so we just took care of the first step of the notes we said. We got the numerator and denominator all simplified. Now we got to do numerator and denominator together. So first of all, let's tackle these coefficients. That's basically a fraction, so let's simplify it a little bit. What can I divide 4 and 6 by? And you can even write it over here separate if that's helpful. If you're able to do it in your head, awesome. That works too. You can divide them both by 2 though, and you'll reduce 4 over 6 down to 2 over 3. That would be your reduced fraction. Let's take a look at the x's. We've got x to the 7th over x to the 4th. When you're dividing, remember you're actually subtracting the numbers. Don't get your rules mixed up. So I should end up with x to the 3rd, and it should end up on top because there were 7 here originally. So x to the 3rd goes up there. Same thing with the y's. There were 8 on top, 3 on the bottom. So I'm going to cancel some of them out, which really is just subtracting. And I'm going to end up with y to the 5th on the top of the fraction. Alright, you guys go ahead and try this one. Pause here and then you can check your answer once you've at least tried it yourself. Again, you're really just kind of cheating yourself out of a good practice if you just look ahead. I mean, you can if you want to, but it's not very helpful. So pause here, try it yourself. Maybe you got it right, totally on your own. Alright, here's what you should have gotten. On the top part, you've got a 10. You have m to the 3rd and m to the 1st. Combine those together, you get m to the 4th. And then you just have the n to the 7th there as well. On the bottom, you've got a 5. You have n to the 1st power, n to the 3rd power. If you add those numbers up, you get n to the 4th power. And then there's this m squared there as well. Nothing's really happening with that guy though. You have 10 and 5. Well, what can you divide 10 and 5 by? I can divide them both by 5. So that means I have 2 and 1. We might not need the 1 if there's nothing else there, but we like to keep it there just in case. I have m to the 4th, m to the 2nd. If I subtract them, I end up with m squared, or m to the 2nd on top. Look at my ends now. I have n to the 7th, n to the 4th. If I take the difference, it's n to the 3rd on the top. So there's my answer.